Hi, my name is Robert Wolfe. I'll be discussing research on markedness in visual semantic AI. First, I'll summarize our findings, then move on to background on the AI model we studied and the theory we grounded our research in. Then I'll cover our sources of data, followed by a description of our experiments and results. Finally, I'll discuss the implications of this research for AI and society. The central question of this research was what demographic characteristics are identified by visual semantic AI and what characteristics are assumed to be the norm and left undescribed. The model we examine in this research is CLIP. CLIP jointly trains a language model and an image encoder and uses cosine similarity to pair an image with its text caption. This allows CLIP to rank, retrieve, and classify images using natural language descriptions. So in CLIP, which of these two individuals do you think would be more likely to be associated with a text prompt identifying gender? We provided CLIP with a binary choice. Choose any gender label or choose a person label with gender omitted. CLIP associates images of male individuals with the person label 26% of the time compared to 15% of the time for images of female individuals, reflecting that male individuals are closer to the norm, while female individuals are marked using additional language. In CLIP, which of these individuals do you think is more likely to be paired with a text prompt describing race or ethnicity? The results showed that the person label is preferred 47% of the time for images of white individuals and less than 6% of the time for 5 other races or ethnicities included in the dataset we examined. This indicates that white is a default and that races and ethnicities are marked when they depart from the white norm. And finally, in CLIP, which of these individuals is more likely to be associated with text describing age? We found that middle-aged individuals are much more likely to receive the person label, including 57% of individuals aged 30 to 39. On the other hand, individuals younger than 10 or older than 70 are nearly always marked with a label describing age. This indicates that middle age is closer to the default in the model and that deviation from middle-aged is marked with additional language. We'll briefly review the architecture of CLIP and the representations formed by the model. CLIP forms contextualized word embeddings, sentence embeddings, image embeddings, and multimodal projections of sentence and image embeddings. The CLIP text encoder is based on the architecture of GPT-2. GPT-2 generates contextualized word embeddings to form a prediction of the next word in its vocabulary. CLIP encodes a sentence embedding using this architecture and then projects it to a joint visual semantic embedding space. CLIP learns image embeddings using a vision transformer or a ResNet and also projects those embeddings to the joint visual semantic embedding space. In the joint space, cosine similarity is used to rank, retrieve, and classify images. So that's an overview of CLIP, and now let's discuss what cultural markedness refers to and why it's an important bias to study. Marked categories differ from the societal norm and are described using additional language. On the other hand, unmarked categories carry the assumed meaning, which does not need to be made explicit with additional description. To facilitate this research, we used the FairFace dataset, which includes more than 80,000 images of faces with labels based on gender, age, and race or ethnicity. FairFace includes 2 gender labels, 7 race or ethnicity labels, and 9 age range labels. FairFace does have some limitations which affect this research. Most notably, labels are assigned by other humans, not based on self-identification. We carry out 2 experiments to measure markedness in CLIP. The first directly measures markedness based on associations of encoded images with encoded text labels. and the second measures how similar the image representations of a socio-demographic group are to one another. For our markedness test, we provide CLIP with the option to choose between any of the FairFace labels for a demographic characteristic, or to choose a person label omitting description of that characteristic. We use the text prompt recommended by the designers of the model. Note that this research does not concern itself with model accuracy with regard to a socially defined category. We care only about whether the model prefers to mark an image or to leave it unmarked. For gender, the model is able to choose from the FairFace labels, or it can choose the unmarked person label. We find that male individuals are more likely to be associated with the person label than are female individuals, and that gender labels are associated with female individuals at younger ages than male individuals, with notable differences in the adolescent and teenage years. This suggests that the gender of women becomes salient to AI sooner than it does for men. Next, the model can choose from any of the FairFace age labels, or it can choose the person label. We find that middle-aged individuals are the most likely to receive the person label. Unlike with gender labels, images of younger female individuals are more likely to receive a label with age omitted than are younger male individuals. However, older female individuals are more likely than older male individuals to receive a label describing their age. These differences are further exacerbated when images of individuals who are white and male are compared with images of individuals who are black and female. Next, the model can choose from FairFace race or ethnicity labels, or it can choose the person label. And our results show that white individuals are the most likely to receive the unmarked person label. The results also show that the person label is preferred over race or ethnicity labels increasingly as age increases for both individuals who are white and male and for individuals who are black and female, while there's a stark difference between the two groups across age ranges. Next, we assess the self-similarity of the projected image embeddings for a socio-demographic group. This corresponds to the mean pairwise cosine similarity of the image embeddings. Self-similarity measures the representational uniformity of a group, or the extent to which a group's embeddings are organized around the shared demographic characteristic, like age, gender, or race or ethnicity. Where images are more self-similar, we expect that they deviate more from the cultural norm because the trait depicted has more conceptual salience to the AI model. And results indicate that images of younger individuals and older individuals are the most self-similar, and that images of female individuals are more self-similar than those of male individuals. Moreover, as age increases, the disparity in self-similarity between male and female images also increases. We observe a similar effect for race. Images of white individuals are the least self-similar, and the disparity between white and the most self-similar race or ethnicity increases as age also increases. Moreover, differences in self-similarity are magnified by the intersection of race and gender, with more significant differences at every age range than those based on gender alone. Finally, all of the most self-similar social groups reflect individuals under the age of 10 or over the age of 70, while 6 of the least self-similar social groups reflect individuals who are white and male. So what is most central to the concept of person in CLIP? The evidence suggests that individuals who are white, male, and middle-aged are the least likely to be marked by the model, and have the least self-similar image embeddings, suggesting that this group forms the default representation of person in the model. Our results also indicate that bias varies significantly based on the age of individuals depicted. While 91% of women between 30 and 39 are marked with a gender label, only 60% of women older than 70 are marked with a gender label. Suggests that even bias work that does not primarily concern itself with age may want to consider age as a factor. So what are the potential societal effects of markedness in AI? The results show that language and image AI is more likely to identify the socially defined demographic features of underrepresented individuals. Given the ubiquity and ease of use of AI, these systems may reinforce that these characteristics differ enough from the norm that they need additional description in language, which could influence human social cognition. Our research does have limitations. First, we assessed only the most commonly used CLIP model. We also note that changing prompts will have an effect on the results because CLIP representations are contextual. And finally, the analysis is limited based on the labels and design of the FairFace dataset. Future work might expand this analysis to additional visual semantic AI architectures and assess the impact of markedness in downstream applications of language and image AI. Thanks so much to my brilliant collaborator, Dr. Aylin Caliskan. Please feel free to get in touch with us at the emails provided. Our code has been made available publicly on GitHub. Thanks so much.